Hey guys, Marco here from Aviator Live CS. Welcome back to my channel. Today we'll start talking about the electrical system for the Boeing 737-800 NG. It's quite a long system, so we will do different parts. Today we are going to start with part one, and let's see what we are going to review today. So today we will talk about APU electrical load, limitations, electrical power generation, system overview, controls, and indicators. All right. So let's start talking what we can find in FCOM 1 about the APU electrical load. And they talk about the APU bleed as well, but I just highlighted here what is related to the electrical load. So airplanes operating under FAA rules, in-flight APU bleed plus electrical load, maximum altitude 10,000 feet. Airplanes operating under FAA rules, ground only, APU bleed plus electrical load, maximum altitude 15,000 feet. APU bleed max altitude 17,000 feet. And here is what we are talking about, electrical APU electrical load, maximum altitude 41,000 feet. Now let's talk about the electrical power generation. And we'll start with the engine generators. Primary power is obtained from two engine IDGs. So you can see both of them here. The IDG maintains a constant generator speed throughout the normal operating range of the engine. An integral electromechanical disconnect device provides for complete mechanical isolation of the IDG. APU generator, as you can see there, the APU generator can supply power to both AC transfer buses on the ground or in flight. As the only power source, the APU generator can meet electrical power requirements for all ground conditions and most flight conditions. External ground power, you can see the receptacle here, an external AC power receptacle located near the nose gear wheel well on the lower right side of the fuselage allows the use of an external power source. Status lights on a panel adjacent to the receptacle permit the ground crew to determine if external power is being used. When connected, external power can supply power to both transfer buses. And then we'll talk about the ground service. For ground servicing, a ground service switch is on the forward attendance panel. The switch provides ground power directly to the AC ground service buses for utility outlets, cabin lighting, and the battery charger without powering all airplane electrical buses. The ground service switch is a momentary push button, and it is overridden when both AC transfer buses are powered. Let's have an overview of the system. The primary electrical power is provided by two engine integrated drive generators, or IDGs, which supply three-phase 115 volt, 400 cycle alternating current. Each IDG supplies its own bus system in normal operation and can also supply essential and non-essential loads of the opposite side bus system when one IDG is inoperative. Transformer rectifier TR units and a battery charger supply DC power 28 volts. The battery also provides backup power for the AC and DC standby system. The APU operates a generator and can supply power to both AC transfer buses on the ground or in flight. What we're going to read here, it's really important to know. There are two basic principles of operation for the 737 electrical system. There is no paralleling of the AC sources of power. The source of power being connected to a transfer bus automatically disconnects an existing source. The electrical power system may be categorized into three main divisions: the AC power system, the DC power system, and the standby power system. Right? Here we have a nice diagram I got from the Boeing 737 MRG app. Thank you to Captain Pat Boone for letting me use some of his content here. So you see the different buses here, and they have colors, and let's see what that means. The blue ones, transfer buses, they take heavy loads. The orange one, transfer buses, essential loads AC. The yellow ones, DC buses, essential loads DC. You can see them here. Main utility galley buses, non-essential loads, as you can see here. The red ones, battery standby buses, loads essential for safety of flight. And the gray ones, external service buses, external and ground service. So we can have an idea of the loads these buses can take. So let's keep reading here. The IDGs supply power directly to the AC transfer buses. And again, we can see the IDGs here, and you can see they are connected to the AC transfer buses. Each IDG is controlled by a generator circuit breaker, or GCB, which you can see here. GCB1, GCB2. The transfer buses are connected by a tie bus and bus tie breakers, or BTBs, which you can see here. BTB1, BTB2. The AC transfer buses supply power to the remaining AC buses. So you can see here, AC buses right there. And the transformer rectifiers, or TRs. So you can see this line connects to the TRs right there. All right. And here's TR3. The TRs are the primary source of power to DC buses. So you can see the TRs feeding the DC buses here. All right. The battery energizes the hot battery and the switch hot battery buses when AC power is not available. It can also supply emergency power for the battery bus and AC and DC standby buses. So right here you can see the battery bus. Here we can see the switch hot battery bus. Here's the hot battery bus. Okay, and here you can see the battery. In case we have an auxiliary battery installed, you can see it here. The battery charger maintains the battery's charge. The battery charger is also the normal source of power for the hot battery and switch hot battery buses. The APU operates a generator which can supply all necessary electrical loads in flight or on the ground. External AC power can also be used on the ground. It is connected to the airplane through a receptacle on the lower right side of the fuselage. The ground service switch lets you connect external power to the ground service buses from the forward flight attendant panel in the cabin. Now let's talk about some of these buses here. Let's start with the switch hot battery bus. It is powered when the battery switch is on. Essential systems like fire protection, left IRS, ADIRUS are connected to this bus. Now if we talk about the hot battery bus, it's always powered regardless of battery or standby power switch position. Essential systems like fire protection, fuel spark valves are connected to this bus. Now let's talk about the remote control circuit breaker, or RCCB. It's normally open and it closes when TR3 fails and standby power switches in auto, AC transfer bus 1 or DC bus 1 loses power, standby power switch in bad. When the RCCB is closed, it lets both batteries supply power to the standby system. Now let's talk about the ground service buses. Are powered either from on-site AC transfer bus or directly from ground power source. Pushing the ground service switch located on the forward attendant station will power ground service buses 1 and 2 from ground power. This allows for servicing of the airplane without the need to power up the flight deck. Now let's talk about the BTB, or bus tie breakers. And you can see them here. They are controlled by Bus Power Control Unit, or BPCU. The BPCU ensures that there is no paralleling of the AC system, monitors external power contactor, and controls load shed function. It is not possible to power one transfer bus from APU and the other one from the ground power, as this would contradict the no paralleling rule. So now let's talk about the controls and indicators we have for the electrical system. We'll start with the AC and DC meter and panel. Number 1, DC ammeter indicates amperage of source selected by DC meter selector, which is this one here. Number 2 is the DC voltmeter, indicates voltage of source selected by DC meter selector. Number 3, AC ammeter, indicates amperage of source selected by AC meter selector, which is this one here. Number 4, frequency meter, indicates frequency of source selected by AC meter selector. Now we'll continue with number 5, AC voltmeter, indicates voltage of source selected by AC meter selector. Now let's talk about this light here. Number 6 is battery discharge light. When it is illuminated amber, with battery switch on, excessive battery discharge is detected. TR unit number 7, illuminated amber. If we are on the ground, any TR has failed. In flight, TR1 failed, or TR2 and TR3 failed. If we talk about the elect number 8 light, illuminated amber, a fault exists in DC power system or standby power system. And this note here, it's really good to know, operates only with airplane on ground. Number 9 here is the maintenance test, maintenance switch is used by maintenance. Number 10, DC meter selector, you can see it here, selects DC source for DC voltmeter and DC ammeter indications. The test is used by maintenance. Now we have the battery switch here. It has 3 positions: off, bad, and on. Let's read about them. Off removes power from battery bus and switch hot battery bus when operating with normal power sources available. Removes power from battery bus, switch hot battery bus, DC standby bus, static inverter, and AC standby bus when battery is only power source. In the on position, which is guarded, provides power to switch hot battery bus, energizes relays to provide automatic switch of standby electrical system to battery power with loss of normal power. Number 12, this one is the AC meter selector, selects AC source for AC voltmeter, AC ammeter, and frequency meter indications. Test is used by maintenance. Now we have the cabin utility switch right here. You can see 2 positions, off and on. In off, it removes electrical power from galley and cabin equipment systems, including all 115 volts AC galley buses, left and right recirculation fans, forward and aft door area heaters, drain mast heaters, lavatory water heaters, logo lights, potable water compressor, 115 volt AC shaver outlets when installed. In these models here, the LED cabin lighting. In on position, supplies electrical power to galley and cabin equipment. Now, if we talk about the IFE pass seat switch, this switch here, also 2 positions, off and on. In off, removes electrical power from installed components of the passenger seats, in-flight entertainment systems, and other power systems, including 115 volt AC audio entertainment equipment, 115 volt AC video entertainment equipment, cabin telephone equipment, fax machine, 28 volt DC video equipment and passenger seat electronic outlets. And in these models here, the flight deck door surveillance system. In the on position, supplies electrical power to install components of the passenger seats, in-flight entertainment system, and other power systems. Now let's talk about the generator drive and the standby power panel. If we talk about the generator drive lights, illuminated amber, integrated drive generator, or IDG, low oil pressure caused by one of the following: IDG failure, engine shutdown, IDG automatic disconnect due to high oil temperature, IDG disconnected through generator drive disconnect switch. Number 2, let's talk about the generator drive disconnect switches guarded. You can see them here. Disconnects IDG if electrical power is available and engine start lever is in idle. IDG cannot be reconnected in air. Okay, that's good to know. Number 3, let's talk about the standby power off light. Illuminated amber, one or more of the following buses are unpowered: AC standby bus, DC standby bus, or the battery bus. Now let's talk about the standby power switch, which you can see here. It has 3 positions: auto, off, and battery, or BAT. In the auto guarded position, in flight or on the ground, an AC transfer bus is powered. AC standby bus is powered by AC transfer bus 1. DC standby bus is powered by TR1, TR2, and TR3. In flight or on the ground, loss of all AC power. AC standby bus is powered by battery through static inverter. DC standby bus is powered by battery. Battery bus is powered by battery. In the off position, which is the center position, standby power off light illuminates. AC standby bus, static inverter, and DC standby bus are not powered. Battery, BAT, is an unguarded position. AC standby bus is powered by the battery through a static inverter. DC standby bus and battery bus are powered directly by battery. All right, now let's talk about the ground power panel and bus switching panel. Here we have the ground power available light, illuminated blue. Ground power is connected and meets airplane power quality standards. If we talk about the ground power switch here, 3-position switch, spring loaded to neutral. Off, disconnects ground power from AC transfer buses. On, if momentarily moved to on position and ground power is available, removes previously connected power from AC transfer buses and connects ground power to AC transfer buses if power quality is correct. Now, if we talk about the transfer bus off lights, illuminated amber, related transfer bus is not powered. The source off lights, illuminated amber, no source has been manually selected to power the related transfer bus, or the manually selected source has been disconnected. If a source has been selected to power the opposite transfer bus, both transfer buses are powered. Okay, let's talk about the gen off bus lights. Illuminated blue, IDG is not supplying power to the related transfer bus. If we talk about the generator switches, 3-position switch, spring loaded to neutral. Off, disconnects IDG from related AC transfer bus by opening generator circuit breaker. On, connects IDG to related AC transfer bus by disconnecting previous power source and closing generator circuit breaker. Now let's talk about the bus transfer switch. Auto, guarded position. BTBs operate automatically to maintain power to AC transfer buses from any operating generator or external power. DC cross-tie relay automatically provides normal or isolated operation as required. In the off position, isolates AC transfer bus 1 from AC transfer bus 2 if one IDG is supplying power to both AC transfer buses. DC cross-tie relay opens to isolate DC bus 1 from DC bus 2. If we talk about the APU gen off bus light, illuminated blue, APU is running and not powering a bus. Now let's talk about the APU generator switches. 3-position switch, spring loaded to neutral. In the off position, APU generator powering both AC transfer buses. Moving a single APU gen switch to off illuminates related source off light. APU continues to power AC transfer buses. Subsequently, moving other APU gen switch to off disconnects APU generator from type bus and removes APU power from AC transfer buses. APU generator powering one AC transfer bus, IDG powering one AC transfer bus. Moving related APU gen switch to off disconnects APU generator from type bus and AC transfer bus. IDG powers AC transfer bus. Now, if we select on, neither AC transfer bus powered by IDG, moving a single APU gen switch to on, connects both AC transfer buses to the APU generator, disconnects external power if connected, opposite source off light illuminates until the other APU gen switch is moved to on. Both AC transfer buses powered by IDGs. Moving an APU gen switch on powers the related AC transfer bus from the APU generator. Other AC transfer bus continues to receive power from the IDG. Lastly, we'll talk about the ground service switch. A momentary push button switch provides manual control of ground service buses, enables servicing airplane using external power without activating AC transfer buses. When this light is illuminated white, on connects external power to ground service buses, off disconnects external power from ground service buses. So with the ground service, guys, we finished part 1 of the electrical system. I hope you find these videos useful. If you like them, please give me a thumbs up. If you're not subscribed to my channel, please do it now. And if you think these videos could be interesting for somebody else, please share them. This is going to help me a lot to grow the channel. Hopefully, I'll see you next week, guys. We will keep talking about the electrical system and we'll continue with part 2. Until then, please take care and I hope to see you soon.